Let's move on to topic B, different methods of clustering. K-means is a useful clustering algorithm because it is simple, widely applicable, and scales very well to large datasets. However, it is not the only clustering algorithm available. Each clustering algorithm has its own strengths and weaknesses, so it's often worth having more than one in your toolkit. We'll look at some of the other popular clustering algorithms in this section. Mean shift clustering. Unlike k-means, it does not require you to specify the number of clusters. Mean shift clustering works by starting at each data point and shifting the data points toward the area of greatest density. When all of the data points have found their local density peak, the algorithm is complete. This tends to be computationally expensive, so this method does not scale well to large datasets. It does not require you to specify the number of clusters, unlike k-means, but you need to choose which hyperparameter to use. Why don't we go ahead and do an exercise for this? Performing mean shift clustering to cluster data. In this exercise, we will use mean shift clustering to cluster the age and income data of customers from the aging.csv dataset. We imported pandas and loaded the age and income data from the aging.csv dataset into a data frame named aging_df. Now we standardized the data and stored the standardized values in the Z-income and Z-age columns. Now we need to perform mean shift clustering on the standardized columns of the data. First, we are going to import the cluster module from the sklearn package and also save the standardized columns to X. Now we use the estimate bandwidth function to estimate the best bandwidth to use with a quantile parameter set to 0.1. We trained the model with the estimated bandwidth and set the bin seeding to true. This speeds up the algorithm actually. And finally, we fit the model to the data. Now we printed the resulting number of clusters by finding the number of unique labels that mean shift clustering has created. Next, we should plot the resulting clustering by importing matplotlib, defining the shapes and colors we will use for the plot, and looping through the scatter plot each cluster. This is also what you should get when you're repeating the steps I'm showing you here. So congratulations, you have successfully used mean shift clustering to cluster age and income data. In the next section, we will learn about other clustering algorithms. Now k-prototypes and k-modes clustering. Clustering is a type of unsupervised machine learning that looks for groups or clusters in data without knowing them ahead of time. K-means doesn't work for categorical variables. K-modes works only with categorical data. Base is the centroid of the most common category in the cluster. K-prototypes works with mix of categorical and continuous variables. Mixes the ideas of k-modes and k-means basically. The centroid is one of the data points in the cluster. Now it's time for another exercise to see what we're talking about here. Clustering data using the k-prototypes method. For this exercise, you have been provided with the age education.csv dataset containing demographic data on the age and educational attainment of 1,000 customers. Now we need to create customer segmentations with this data by applying k-prototype clustering to data that has a mix of categorical, which is education, and continuous, which is age, variables. As always, first we imported pandas, and then we read in the data in age education.csv. Let's inspect the data using the head function. The first 5 rows of the data will look as follows. Now we standardize the age variable since it is our only numeric variable, and we stored it in the ZH column. Now for the next step, we are going to need a package that is not pre-installed with Anaconda, so we need to install it. Let's do it together. We need to find Anaconda prompt in our programs. Once we have Anaconda prompt launched, we are going to type pip install K-modes and press enter. I had already installed this package into my computer previously, that's why it says that requirement already satisfied. But you should be able to install this package into your computer with this command. Now that we have K-modes in our computer, let's go ahead and import K-prototypes from the K-modes module. The K-modes module expects NumPy matrices rather than pandas data frames. So we converted the standardized age and education columns as a matrix in the X variable by using the values function. We performed K-prototypes clustering using 3 clusters, specifying the education column in column index 1 as categorical, and saved the results of the clustering as new column called cluster. Please note that if all variables were categorical, we would use K-modes instead of K-prototypes clustering. The code would be the same, except all references to K-prototypes would be changed to K-modes. Now in this step, I created dummy variables for our categorical variable using the pandas getDummies function and concatenated them onto our data frame so we can analyze the results. We plotted the proportions of each educational level in each cluster in a bar plot by looping through each cluster, filtering to the data points in the current cluster, and storing the result in cluster_df, calculating the proportions using the pandas mean function, and finally plotting them using the matplotlib bar_h function. Your results should look like this. You should note that we use this method of visualizing the education data instead of the usual scatter plots because the categorical data increases the dimensionality. If we use dimensionality reduction to visualize the data, we would not be able to visualize how the clusters capture the different education levels. Now, congratulations, you have successfully used K-prototypes clustering to segment people based on their age and educational attainment levels. Cluster 0 captures college-educated customers. Cluster 1 captures those with a high school education, and Cluster 2 captures those with less than a high school education.